So last class we had a session on maze. Remembered? Anybody remember? Did you try?
Yes, sir.
Did you try the maze?
Sir, but I couldn't make it properly, sir.
Will you wait for this week also and check it out in internet and try it out? Otherwise, I'll have another 10 minutes in the next week. Okay?
Sir,
Because we'll tell me.
it for the Leibniz, the last class?
Yes, labyrinth was there. I just talked about labyrinth and also about maze, how to create maze. Maze is one of the wonderful concept. Actually, there are a lot of things one can learn from mazes. Okay, so that's why I just started with the maze last week, and I'll continue the next week. You try for maze. You type maze, various kinds of mazes, and other things. You can do it. That's what actually I did with how the maze can be done. Today again, I say play with maths. So basically, maths means I told you have to find sequences. Look at the sequence. Some patterns are always found in the numbers. How the numbers are related with each other, or find a kind of pattern in numbers. Similarly, we can find a pattern in shapes. Is it not? So can you identify some of the irregular shapes here? I think, can you see these things? What are not familiar to you? Can you read those things which are not familiar to you? Can you one which you are not familiar?
Trefoil.
This shape you would have seen, but this shape is called trefoil. This is again, this shape is known. Maybe some of you did not know the name. Normally we use this called crescent. Call it. But populars are parallelograms.
So,
You know it? Tell me.
so that last but ones.
This one.
Yes.
Quatrefoil. That I'll come back to you. This is having 3 arcs. Here you can see 3 arcs. Here you have how many arcs?
4.
4. Like that increase. This is 4 times. Quarter. 4 times like that. Okay. Tree. Like that. It's a trefoil. Okay. You can remember that. You can go on finding a name for all those things that you have to discuss, because only we are always talking about what is known to us. What actually other shapes which are known will not be able to know. These shapes play a key role in understanding and training machine language. Okay. You look at one picture. I'll show you. What is this picture? Anybody can identify? Again, the patterns are there.
Sir, the first one is chair, second one is cycle.
Okay.
The third one is actually a aeroplane or something. a
Okay.
jet.
Okay. What are the things that other things that you can compare? It's having color. It's
Yeah,
having
The color.
like a color.
colors.
And each color, if you look at, there have been some kind of shapes, some kind of patterns. It will identify the color and identify a part like that. Some kind of part. So a shape and a part. A shape and a part. If they are able to identify a particular shape and as a part, shape and a part. Now I can think what this all information is about. It is a data set.
Sir, I think all the blue color indicates circle.
Not necessary.
Like dark blue?
No, not necessary. So each shape has been split into different colors, and each color will tell something details about a shape. So this kind of you can always train the machine to make it into shape, to make it into colors, and identify. Later this can be trained to identify a kind of object. Now you can understand these are the data kind of things which is actually used to data set as a data set to the machine learning. Did you get the what I am talking about it? You have to train a machine to identify a table. You have to train a machine to identify a tape, whatever objects that you find around us. So first of all, it has to break into smaller shapes of known thing and identify with a color, identify shapes and colors. Then the pattern can be understood and analyze and write a logic to identify this is similar to a cap, this is similar to a cup, this is similar to a. That can be trained. Is it not? What I am talking, you are understanding?
Yes, sir.
ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? ಯಾವುದೇ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ನ ಆಕಾರಗಳನ್ನ ನಾವು ಬೇರೆ ಬೇರೆ ವಿಂಗಡಿಸಿ ಭಾಗವಾಗಿ ಮಾಡಿ ಅದರ ನೋನ್ ಆಕಾರಗಳು ಗೊತ್ತಾಯ್ತು ಅಂತಂದ್ರೆ, ಇಫ್ ಯು ನೋ the known parts, then I can compare the one or more like all those shapes can consider a shape to another thing, like how a cup can be broken into an arc. Can you a cylinder, you can break the cup into two, coffee cup, coffee mug, an arc will be there, a cylinder will be there. So that means whenever you see outside, all the shapes that you know, it is actually not individually you will see, you see as a part of it. So shapes and patterns makes lot of things to understand, and it is used much of the things. So as a program to learn programming, to use shapes in programming, and like 2D shapes, 3D shapes, he was talking about today 3D printing and other things. So there are a lot of tools which have been created using all these basic shapes. From the basic shape, a tool will be created in any of the graphic software. Did you get what I'm saying? First, you should know the basic shape. Basic shape, we can create a complex shape. A complex shape can stand as a candidate of 2D kind or a 3D kind. Did you understand what I'm talking? ನಾನು ಹೇಳ್ತಿದ್ದು ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ಸಣ್ಣ ಸಣ್ಣ ಆಕಾರಗಳಿರುತ್ತಲ್ಲ, ಅದರಿಂದ ನಿಮ್ಮ ಹೈಸ್ಕೂಲಲ್ಲಿ ಯಾವ ಶೇಪ್ ಇರುತ್ತೋ ಅದಕ್ಕಿಂತ ಒಂದಷ್ಟು ಹೆಚ್ಚು ಶೇಪ್ಸ್ಗಳನ್ನ ತಿಳ್ಕೊಳ್ಳೋಕೆ. ನೋಡಿ ಇಲ್ಲಿ, what are the shapes that you can find here? You can see here. What actually that one? A circle. What actually happening here? So two circle, actually you just copy it on right side, it will become a arc like this, a combination of two circle with different diameters. And you can see that if you cut it, you get an arc, is it not? Similarly, here an ellipse, which you give a twist, or if you cut it, you can get a heart shape. Similarly, a camera aperture is like that only created. A camera aperture is a part of a polygon and a circle together makes a aperture. Did you understand what I am saying? ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? Are you catching what I am saying? Hello? Hello? Anybody is there?
Yes, we are there.
Okay. Now the question is, this is the reason why I take TanGrams as one of the basic, a toy kind of thing, a playful things, which actually basically you know it. From the TanGram you can learn a lot. From the TanGram you can learn a lot. Got it? So this is actually a TanGram is basically a mathematical tool. So TanGrams, high school mathematics can be learned with TanGrams, many kind of things, and TanGram you can create it. Once you're able to identify the different things that you know, so what are the things that you can now identify here? How many circles are there? My question is right or wrong? Circles is there?
First one is quadrilateral.
No, understand my question. I asked
No,
how many
sir,
circles?
there is no circles.
No circle. All are made up of a lot of straight line segments. And these are all known as triangles, a square, and a parallelogram of different sizes. 3 triangles of different size, 1 square, and 1 parallelogram. So basically, again, this itself is inside a square. This itself is inside a square. Have you seen the TanGrams?
Yes,
Have
sir.
you-
First standard UKG, LKG, they had given tangrams for us to play with it and do many other shapes.
Yes. Did you create a TanGrams?
Yes.
Did you create a TanGrams at that time? Or you have a TanGram in your house? Or you want to create now? These are the question I'm asking. Why TanGrams? I'll come back to you. Various kind of TanGrams are there. So basically, this one TanGram that you can create. I told last time I told many kind of things TanGram as a standards. So this is actually started from many China and other things. I'll not story you the story. My question is, various kinds of TanGrams are available. See, like one, the circle is there, arc is there. Yeah, so from a circle we can make a TanGram. Somebody is talking. Okay, can you see what is the name of this TanGram?
Circular puzzle.
Circular puzzle. What is this?
Magic egg.
Magic egg. Okay, you can see that I have that magic egg here box. This is the magic egg box, and it is magnetic. To be frank with you, this is magnetic magic.
Yes, sir. Even I have the tangrams, not like the circular thing. It is the magnetic one only, sir.
So this is the magnetic one. This is from This is from Play Panda.
Yes,
Okay.
sir.
This is
Same.
from Play Panda. They have various kind of TanGram. Why they created this toy? You can create it. There is no need to buy. Also, I'll tell you how to do it also now. So if you are able to do it, the question is about understanding a TanGram. Why TanGram plays a key role to understand shapes and patterns, thereby understand a lot of 2D, 3D animation, 2D understanding 2D graphic, 3D graphic. All of the things. Once you are able to high school level, you should be able to identify a part of a complex shape. Part of a complex shape, whether it's a 2D or 3D. For that, you have to understand the patterns. For that, you have to understand the patterns. For that, you have to understand the line segment. For that, you have to understand the arc, a curve segment, a part of a curve, a part of a circle, a part of an ellipse, like that. So if you are able to, first, don't go to the mathematics, don't go to the algebraic concepts, don't go to the calculus concept. First, you understand what are the basic lines, what kind of lines are, whether it's a straight line or a curve line, whether it's a part of a curve, there's a part of a line, what is that part is called, all these things plays a key role. So in order to do that one, if you start playing with these kind of toys, the sense, the mathematical sense of visual sense, it will develop into a visual sense. Those visual sense will help you to understand, develop any 2D graphic or 3D graphic that we are talking about it, or using a 3D printer or a 2D printer with the different tools which has been created. I told the tools can be created once you understand a shape, and the tools have been a part of any software. So all those things is a part of it. So first of all, if you understand, you can make using any programs. That's a different question. How to do it, you will do in your higher classes. But the question is, first you understand, in TanGrams itself there are various kinds of TanGrams. Those are basically like, you have a TanGram, popular, broken heart, here you can see Vietnam circle, Pythagoras, this is a Pythagoras, Archimedes, a Mongolian puzzle. All these things are part of various kind of project that you have to know. So for each that you find, you may have one or more kind of thing. So always we will be introduced to one kind, but when you start researching or going into the whole field of understanding, you'll find various kind and various level. Not necessarily that one, you will find like all the pieces together, a box of tangrams, a box of in the form of either plastics or a papers, or even in the form of wooden pieces. All these things are, it's a multiple kind of tangrams are available. Why do you need it? This is a question. Why do you need it? ಅದಕ್ಕೋಸ್ಕರ tangrams ನ ನೀವು ಅಭ್ಯಾಸ ಮಾಡಬೇಕು. What you will do it? So my question is about, you can make all types of shapes with that one, starting with animals, or you can have basic shapes and other things that you can do it. So basically you have to understand how the tangrams are done. Are you interested to do it now? Can you take some white paper?
Yes, sir.
So in the white paper, can you make a 4 cross 4 square? Here 4 cross 4 square is there.
Sir,
Okay.
is A4 sheet enough?
Sir, is it like a maze now?
No, it's not a maze now. I want you to do in a paper this. Okay, I'll just click it
Paper
and
size?
and I'll show it in Excel also to do it. First of all, I'll just do it. So what actually the square looks like this. So I'm doing it here. You can see how many
Sir,
squares are there.
paper size?
Paper size, any paper size, doesn't matter.
A4
You have to
sheet,
make
rectangle.
whatever, you have to make like 4 rows and 4 columns of equal size. Okay, scale size, you can take a scale size. You can take a scale size and make 4 rows and 4 columns.
Yeah, so that's easy.
That's easy, nothing else. Is it difficult? Or you can first, you can draw it. So you can draw 4 rows, 1 2 3 4. 1 2 3 4. We are actually making the tangrams.
Just a second, sir.
The reason is, so once you make a 4 cross 4, so this 4 cross is a very interesting kind of what I can call it as. Many things can be done with 4 cross 4. So I can create a lot of puzzles with 4 cross 4. So it's a matrix. It's like a matrix. 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4. Correct? You can write the diagonal. One diagonal.
Sir, actually, in our school, we were we did the magic squares
Hmm.
for our birth date.
Hmm. Hmm.
It was really interesting, sir. Like
That magic square, definitely I like. Ramanujam number you can take, just replace it with your birth date in the order.
sir.
It's a very simple thing to do it. But 4 cross 4, I'll tell you very interestingly, 4 cross 4 puzzle is interesting. Can you? I'll show you that 4 cross if you want. That is the next level of understanding. Put 4 cross 3. You can start with white. 2 cross 2 magic square is not there. 1 cross 1 magic. 2 cross 2, 3 cross 3, 4 cross 4, and you can go for n
but
cross
we
n.
did for 3x3, sir.
3 cross 3 is easy. You can learn
sir,
you can learn in many ways. There are more than many techniques to write 3 cross 3. Even you can have a rangoli design to do it. 3 cross.
Yes. I could do it in only one day, sir. It was easy.
Okay, we'll try it. First of all, we'll look into the first this part of it, tangram part of it. So tangram. So I need squares. I need a parallelogram, and I need small squares, or a take a big square. In small square, you can see how many 16 squares are there? Is it clear?
Yes,
16
sir.
square. So in this, you can make a diagonal. This blue indicates a diagonal here. This blue color, can you identify?
Mm.
So that if you just cut, you can make a bold with your paper, bold line, and also you can make a bold line starting with this diagonal and end up to this one, not one more square. So you can make two diagonal. One diagonal is it's also a mathematical learning. So one diagonal of full length starting with this and this ending with this. The other diagonal is having, let's say each square will have a diagonal, one diagonal, two diagonal, three diagonal. You can understand here one diagonal, two diagonal, smaller diagonals of the smaller
Yes,
square.
sir.
So smaller diagonal, 3 parts here, smaller diagonal, 4 parts here. Any problem?
No, sir.
So now that in this, if you make these two become the big two triangle pieces,
Sir, I have done it like this.
then here you can take
Sir,
this
I have
square
done this with the marker.
marker. Then you have the parallelogram here. Where is the parallelogram? Show me. Where is the parallelogram?
Sir,
In this.
just a minute.
So in this is the parallelogram part of it. Here marked, not marked. So you can write here. So this is the parallelogram part. Got it here. So one small square. Sorry, in this, in this small square, you got it. So this part is as a diagonal. You take this diagonal and this diagonal and here and here. So you got a parallelogram here. Got it? So this diagonal and this diagonal and this straight line makes a parallelogram here. Whether my mouse visible? Mouse visible in your system? Mouse over is visible.
Yes, sir. Yes, sir.
Okay, I'm just starting here. This is the one parallelogram. This another. What is this shape? This shape is. This is a
triangle.
not a square.
Diagonal.
Triangle.
Diagonal.
This is a diagonal. Is a part of this triangle. This
Sir,
triangle.
see this.
Yes. So we can just do it. I'm just seeing it. So yours is visible. So similarly, you can make a square here, and you can make a here parallelogram, and a small triangle, and a small triangle of same size, and this one. If you make like that, you will get a pieces like this.
Wait, sir. Please show before.
Yes, sir.
So how many pieces you got it? How many pieces you got it?
6.
No, you should get 7 pieces. So
Sir, is it right like this?
definitely, is it correct? So one parallelogram you are missing. Parallelogram is it should make a parallelogram here in this line. Parallelogram. So that line is missing. You can see here. From this, can you take like this? So otherwise, I'll take Excel and do it. Shall I take Excel and do it? You want to show
Sir,
me?
1 minute. Show that slide.
Sir, but I can't understand what are you telling me.
So you need 7 pieces. I need a parallelogram here. This is a different kind of things. I need a parallelogram, parallelogram. You got it? Parallelogram. You know it. That can be obtained by this diagonal, this diagonal. My mouse is now visible.
Yes, sir. Sir, I
This
have done it like that only, sir. See here, one diagonal.
And here on diagonal. And this line, this whole part is a parallelogram.
Sir, I have done it like that only, sir. Here one diagonal, here
Okay,
one
they are missing. The parallelogram is missing. You have to write that parallelogram. Here on this small circle, you are missing. This these are small triangle. You cover this small triangle. So this is color. I have to make it. Okay, I have to use an Excel to do it. Got it? This parallelogram here. Can you see the parallelogram here? A square, small square, a small square, a small triangle, and a small triangle. All these 3 put together, it makes a parallelogram.
Okay.
And this small triangle makes us one more triangle. These 2 small triangle making a triangle here. This triangle, this square, and this triangle makes a parallelogram. This triangle, and this square makes a bigger triangle. This triangle, and this triangle makes a smaller triangle. This small triangle, this 2 and this 3, 1, 2, 3, 4 triangles plus these 2 square makes a bigger triangle. Similarly, here also same 1, 2, 3, 4 triangles, 1, 2. This also able to count how many in each of these things. Let's say in a bigger triangle, how many triangles are there or squares are there? In small triangles, how many triangles are there? And again in parallelogram, how many triangles are there and how many square also there? Is one of the simple questions. So it simply
So
starts
how
like
to
this.
make the parallelogram?
Okay, now I'll just show it once again. Okay, you know there are how many? 4 are there. Okay,
Not clear, sir.
not clear.
No,
Okay,
sir. Your
I'll.
screen is blur.
This is also blur. No, okay, see here. Blur,
No, no.
not visible.
Visible.
Okay, now one triangle here. Arrow mark, one triangle.
Sir, is this how we made those division?
Mm, not proper. Not proper, yeah. So here in that you have not got the parallelogram. Yes, here it is the parallelogram.
Yes,
Yes,
sir.
but
Here it
but
is.
the small triangle is not properly made. This small triangle, you know, next to the square there is a small triangle.
This one.
That small triangle should be proper. Okay, that's all. Okay. So there are along with the square there are two small triangle and a parallelogram. In this area you got a triangle, square, triangle, parallelogram. Here I got triangle. Here I got two triangles. One triangle, two triangle, one small triangle, one square triangle, one small triangle, one parallelogram.
Sir, even here we can get a parallelogram here.
But you will get it. But in order to make
And a
proper
small.
okay, or it will be like any of the pieces. I'll show you. Just a minute. I'll pick up my.
Sir, please move the slide. Next one you had numbered it now.
So these are the two triangles. Can you get it? Two triangles visible.
Yes,
Okay.
sir.
So next you have a smaller triangle on the top.
This one?
Here, the smaller triangle you can have it. You know, in this smaller triangle comes like this. Okay, and then square comes out it. Since I'm holding, I'm not holding. Okay. Okay. This should be here. This will be like this. I'm talking about one part of it where actually your small triangle and parts are coming like that. So then a smaller triangle will be there. Here it will be smaller triangle, one more. Then there will be a parallelogram. There will be a parallelogram like this. So it will be like that only. That's what actually say. Here is a parallelogram. Here is a triangle. Here is a square. Here is a square. Or I have to show writing it on that one. Can I write it now? Okay, I'll try to write it with Excel. Okay, I can take Excel. I'll show it in Excel. Okay, I need how many squares and squares? How many? One. I'll just take it. 1, 2, 3,
16.
4, 4, 16. Okay, I'll just block it. Okay, I'll make it as a proper size. Row height I have to do it.
Just a second, I want to off my video.
Okay.
I want to shift the place.
Whether it's visible? Okay. Whether it's visible, square is visible.
Yes,
Okay.
sir.
Okay. Now,
Yes.
what actually? So I said in this you have to write a tool. You can take a drawing tool. You can take any of the drawing tool. Just a minute. So how many squares are there now? From here, just it is going somewhere. From here, you can write a line, cross line like this. Till this, you can write a line, From this diagonal, you can write a diagonal. 1 minute, I want to.
In shapes, you can check, sir.
No, just a minute. Picture load. No, I don't want to take the shape. I want to draw here. Draw lines.
Sir, you can use 3D painter.
Anyway, simple. I want to use these things. Not a problem. Anyway, I'll show it afterwards. Okay, this may take time, which I don't want to waste the time now. I'll do it by the time. Can you not do it like this? So you need a two to this one. One parallelogram should be in the corner. This is a reverse one. So it will be on the corner. This corner, you can do it on the last corner or this corner. You can do in the reverse order also. There is small triangle and a square and a triangle and a parallelogram. Or here triangle, then square, then triangle, then parallelogram. You can do these three pieces will be all on this. Actually, a trapezium. This is a trapezium. Can you see the trapezium here? Can you see the trapezium?
Yes, sir.
A trapezium breaks up into smaller triangle to one square and a parallelogram. Got it? That off diagonal will break into two pieces. Is it clear? Any doubts? Okay, now you can see that. So here is a trapezium. 1, 2. This I'll take 1, 2, 3, 4. This is a trapezium, Can you see the trapezium?
Yes, sir.
My arrow is coming there. Or pointer, I have to take a pointer tool. Pointer tool. Okay, sorry. This time I'm running out of the things. Okay, can you do you have any doubts here? I want to go to next class. Okay, shall I go? Can you create? Anybody has done it? Otherwise, you can have a, once again you try it. You can make a tangram. Tangram consists of how many pieces? How many
7.
pieces? 7 pieces. So you should be able to cut into 7 pieces. So I'll go to the what actually the need of the tangrams. Once you are able to use this kind of concepts in a squares, a maze of let's say I can call it as this also a rows and columns of squares and columns of rows of squares. So if you got any rows of square, you can use the bold lines in order to break that picture into smaller shapes of any of requirement. Once you are able to understand, and you will get a tangrams of various kind, which actually basically you can pick 7 shapes like this. Is it clear? These are the 7 shapes of the tangram. So you will have 1, 2, 3, 4, 5, 6, 7. So it consists of 2 bigger triangles, 2 smaller triangle, a medium triangle, a parallelogram and a square. Once you are able to understand, these tangrams are used for various kind of learning. One is a tangram. Basically, it can also talk about what is a triangle. In the triangle, what you can learn about it. What you can learn about it in the triangle, you will learn about some properties like. So what are the properties? So what is this kind of triangle? Let's say you got a right angle triangle here. You got a right angle triangle. Even that in that right angle triangle, this length is equal to this length. What does it feature? Isosceles triangle. Did you know what is an isosceles triangle? Do you know what is an isosceles triangle?
Yes, only 2 sides are equal.
Only 2 sides are equal. So one of the observation before going, so tangram consists of not only a triangle of a size, that triangle is an isosceles triangle. That's what actually one basic. So in a tangram puzzle, there are how many isosceles triangles are there? Means if you look at all these triangles, the 3 different size triangles are all isosceles triangle. Are all?
Isosceles triangle.
This is what actually the mathematics. So I got one triangle here. I got another triangle. 4 is a triangle. 5 is a triangle. 2 is a triangle. 7 is a triangle. 3 is a triangle. Is it not? Yes or no? Tell me.
Yes, sir.
They are also right angle triangle, They're also not only right angle, one more property that I'll observe, they are also isosceles triangle. So the TanGrams also teaching a kind of mathematics that you know by this kind of concepts. Not only it is applying concepts, it's also to understand an isosceles triangle in a toy like this. So is it not mathematics there?
Yes,
A
sir.
geometrical concept that you study in high schools? Did you study high school isosceles triangle?
Yes, sir.
So a right angle triangle can also be an isosceles triangle
So
if
even in
the
middle school, we're
Yes.
studying about isosceles triangle.
yes, definitely. A right angle triangle you studied, and right angle stand as a candidate to learn a lot of mathematics like Pythagoras theorem, trigonometry, and other things. In a right angle triangle, if two sides, that opposite side and adjacent side, are equal, then that right angle triangle is also an isosceles triangle. That is an observation that you have to do it. That's a mathematical sense that you have to get it. Is it not? Is it not? So
Yes, sir.
a tangram puzzles have 5 isosceles triangle of various sizes, 2 large congruent triangles. If you look at the other part of the story, so 2 triangles you will get it. This triangle and this triangle, they are of the same size. This triangle and this triangle of the same size. They are equal. Their sides are equal. Is it not? And if you look at the angle, their angles are equal. When sides are equal and angles are equal, what kind of property that you assign with that one? They are
Equilateral triangle.
no. When you take 2 triangles and compare, all the sides are equal, all the angles are equal. Then you will come across one property called congruent. Is it not?
Yes, sir. Congratulations.
Yes. So it's not playing. So look at the toys. That's what actually science is observation. Math is also an observation. If you observe, you can understand a theorem. You can understand an idea. You can understand what we are talking about. One word that I used is it is similar. Then we say they are congruent. So congruent is a mathematical term. Similar is a mathematical term. So with the shapes, what is similar we are finding. With the shapes, what is congruent we are defining. And this is what actually first play. Instead of creating shape, we can learn a little bit of mathematics using understanding the vocabulary of mathematics. So that is one is congruent, another is.
Sir, I've made this.
Okay, just show me.
Just a second, sir. I'll have to remove my background.
So whenever you can make a tangrams and ask them to have a 4x4 squares and cut the pieces and okay. Yes. So you should be able to, in a tangram, if you cut the pieces and you can have in your exhibition show, you can explain them. So these are the congruent triangles. This is the property of congruent. What is congruence you can take. What is similar you can talk. What is a right angle triangle you can talk about it. Is it not? So you are actually basically looking at the tangram, you can understand 2 large congruent triangles will be there. One medium size right angle triangle will be there, and 2 small congruent triangles will be there, and 1 square, 1 parallelogram. So this is one standard diagram that you will find in the standard diagram. What you find in a standard diagram, if you say, you can find 2 big triangles, 1 medium triangles, 2 small triangle, 1 square, 1 parallelogram. The 2 big triangles are congruent to each other, 2 small triangles are congruent to each other, and 1 medium triangle is also there. And all these 5 triangles are all right angle triangle. They are also isosceles triangles. This is the notes you have to catch out. So the question is not only about looking at a tangrams. So that is a basic one level. I'm talking about there are many levels of understanding the tangrams. Can we construct a various kind of tangrams? And how many people know about the Pythagoras? Sir also talk about Pythagoras theorem. Did you not tell about the Pythagoras theorem?
Yes, sir.
What actually the Pythagoras theorem says about it?
That the square of hypotenuse is equal to square of 2 sides.
Okay, for each side you take a number. For let's say one of the side, if you call A represent a number. That's a concept. A is a number. B is another side. We call it one side. We call it as an adjacent side to the angle. Other we call it as an opposite side. And whatever the triangle, the third side will be right angle triangle. That will be called hypotenuse. If I represent a C, so the 3 sides can be represented by a number A, number B, and number C. And each of the number can be square. So we always talk about a square of a number. Now we are picking up the 3 different square and relating with each other with a formula called A square plus B square is equal to C square.
C square.
So A is you can think many A's, you can think many B's independently, but we are looking at three different numbers relating with each other, and that becomes an observation. That's what actually conjecture I told start observing, and if you are able to find out a square, sum of the two squares is equal to the other square, and if these number represent the sides of a triangle, so Pythagoras triangles looks at the relation between also numbers independently. If you don't that's why it's called, it becomes a theorem. It becomes a theorem. Later you will come across a to the power of n plus b to the power of n is equal to c to the. Okay, now the question is, such kind of, once you understand the triangles, then you can make various kinds of an object which actually looks like they are not same. They are not actually, this is not an exact cat, is it not? But it is similar to cat. What is this picture? What is this picture? What is this picture? Can you say after the cat, what is the picture? You got it here.
Dog.
Dog. Anybody goes about it? So okay, anyway, what is this? Easy to identify.
Fish.
Fish.
Fish. What is this shape?
Fish.
What is the last one?
Running man.
A
Last
man.
one.
There is a man.
Okay,
A
now
man
Weird
walking.
arms.
so now, even though it doesn't have a man, we are using the basic geometrical shapes which has been done with a tangram to create a look like a similar kind of objects.
Yeah.
Is it not? So, and the same thing, if you treat something like, if you take any random shape and break into smaller shapes,
Yes.
and the computer can also read, this looks like a man, this looks like a bird,
Yes,
this looks
sir.
like a tree,
Yes, sir.
this look like animals, this look like an object. So in order to
Yes.
try and we have to break the shape into smaller shapes of known shape and approximate to the known shapes, and tangram is one of the fundamental concepts help to make a basic shape that you learn. I told basic shapes, we learn a lot of basic shapes, not necessarily only these kind of shapes. You come across a lot of other shapes, like I shown in those.
Sir, like what makes that man not look like a man is his arms and his legs.
Okay, you can think like it, you can abstract it. Mathematics is abstraction of an idea. I told ಗಣಿತ ಅಂದ್ರೆ ಒಂದು ಐಡಿಯಾನ ಒಂದು ಚಿಕ್ಕ ಚಿತ್ರವಾಗೋ ಅಥವಾ ಒಂದು ನಂಬರ್ ಆಗೋ ಹೇಳ್ಬೇಕಾಗತ್ತೆ. ಸೊ ವಿ ಆರ್ ರೆಪ್ರೆಸೆಂಟಿಂಗ್ ವಿತ್ ಎ ನಂಬರ್, ವಿ ಆರ್ ರೆಪ್ರೆಸೆಂಟಿಂಗ್ ವಿತ್ ಎನ್ ಇಮೇಜ್. So your idea is represented through an image, your idea represented with a letter, and all letters has been put into an equation, which into a formula. All these things comes out of first and foremost things. Can you make it as an symbol? Can you make it as an image? Can you make it as a letter? Can you make it as a number? That is one fundamental thing that you have to learn in mathematics. That's called abstract. The word abstract, ಕನ್ನಡದಲ್ಲಿ ಅದಕ್ಕೆ ಏನಂತಾರೆ ಅಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಅಂದ್ರೆ ಹೇಳಿದಿರಾ? ಮೂರ್ತ ಅಂತ ಕರೀತಾರೆ. ಅಂದ್ರೆ ಅಮೂರ್ತ ಅಂದ್ರೆ ಅಬ್ಸ್ಟ್ರಾಕ್ಟ್, ಮೂರ್ತ ಅಂದ್ರೆ ಮೂರ್ತಿ. ನನ್ನ ಹೆಸರು ಕೃಷ್ಣಮೂರ್ತಿ. ಮೂರ್ತಿ ಅಂದ್ರೆ ಗೊತ್ತಾಗುತ್ತೆ, ಐ ಕ್ಯಾನ್ ಸಿ ದ ಶೇಪ್ಸ್. ಅಮೂರ್ತ ಅಂದ್ರೆ ಗೊತ್ತಾಗಲ್ಲ, ಐ ಡೋಂಟ್ ನೋ ವಾಟ್ ಇಟ್ ಈಸ್, ಐ ಕ್ಯಾನ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್, ಇಟ್ಸ್ ನಾಟ್ ದಟ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ. ಸೊ ದಟ್ ಅಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಥಿಂಕಿಂಗ್ ಈಸ್ ಇಂಪಾರ್ಟೆಂಟ್ ಇನ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್. Abstract thinking is important. That abstract thinking can be further symbolized with numbers, images, and letters. Got it? And those strings can be made into an equations and formulas. So every equation is a symbolic representation of ideas. Every formula is a symbolic representation of a idea. So this kind of first shaping is also important. That's why you can make here you can see it. Can you see this picture now? Block correctly. So here is the 4 square. Okay, 4 cross 4. Clear?
Yes.
Now okay, 4 cross. I can just pick up this image and make it big if you want. I'll just check it out. So I'll take this picture, copy this, and put it somewhere. I'll take one more slide, and I can turn it around. I just pull this down. Okay. Now whether it's visible for all of you? Can you make it now? Can you take 4 cross 4? 4 cross 4. So it's actually mirror image of the same thing what I told. Same thing. So here you just have the diagonal, major diagonal, which passes through 4 smaller diagonal, and you got 2 smaller diagonal, and here one smaller, and you got here a middle and a minimum, a small. What is a small triangle and a small triangle and one square and a parallelogram and this one. Now can you not write down, all of you? Can you take down this picture?
Yes,
Who are
sir.
all present? Only 10 are there. All other are gone now. Why? Maths was not interesting today. You
No,
feel
sir.
like that?
There are 15 members.
I am seeing only 10. I don't know, last class some. Okay, anyway, the question is about understanding the shapes makes lot of learning of mathematics. That's the basic thing that I want to put your. If you understand, not only just playing with that one, once you are able to do it, you'll get a lot of things. Like I have an unpacked thing of.
So should we draw this?
If you draw it, it will be easy to identify the 7 shapes. Easy. The
Okay,
bolt it. So you can take from the reverse side. I can take one square and the 2 smaller triangle and write these 2 diagonal, so that this becomes a
Sir, how
mid.
many boxes are? Is this also 4 into 4?
This also 4 into 4. 1, 2, 3, 4. Is the small color blue color is visible here, backside.
Yes, sir.
Visible or not?
Yes, sir. The
Okay,
back,
it is
like a back.
yes, a thin
border.
kind of things. Yes, thin kind of things. Is it clear? So this, if you write it, you can cut it in a thick cardboard sheet. Thick cardboard sheet, you can cut into it. Okay. Why I'm telling you these things? Very simple. Can you create various kinds of TanGrams? That's my fundamental question. If once you are able to understand, you can do it with a 4x4. I'll teach you how to do it for other kind of, like Pythagorean triangle, tangram. How you can do it, and how the Pythagoras theorem can be proved with the tangram. That's my question basically. First, we have to understand the tangram. It will enable us to understand the shapes. The second level is to understand the properties like congruent, similar, all those things. Scaling also can be understood. Take on down. Shall I go for the slide?
No, sir.
No.
Taken down, sir.
No,
It's
sir.
easy. It's easy. What is there?
Not yet, sir. Just a second.
We got all the shapes.
Yes, sir.
Wait a minute.
How many pieces?
Sir, except circle, we got all.
Circle will not be there, definitely. Circle is not a part of tangram here. So it's only about, okay, 1 piece here, 2, 3, 4, 5, 6, 7. You got the 7 pieces.
Sir,
If you cut.
Wait, sir, I'm showing it. Can you see it, sir?
You're not showing. Your video is not displayed. Okay.
Wait,
Summary, your background.
yeah.
Sir, I have made this.
Okay. Anyhow, you understood how to manipulate the whole kind of triangles, small triangles into a parallelogram, small triangles into
Yes,
a
sir. Can
triangle.
you see it now?
Okay, show
Sir,
me.
it is taking time to. Yeah, sir.
Okay, yes,
This one?
definitely. Yes, definitely. You got now parallelograms, but don't write the bold. You should be able to know. And you get the tangrams are available only for very small amount. 100 rupees, you'll get a tangrams in much of the thing. Is it clear?
Okay,
Okay.
sir.
Okay. Now my question is not about understanding. So just
Nothing, sir.
okay, you can take down, bold line also. This is the border. These are the bold line that you have to make it on, so that you get the 7 pieces. So from the tangrams of standard tangram, you can make a 7 pieces. I'm talking about only standard diagram. So those are the 7 pieces that you will get back. 7 pieces. So make your own tangram puzzle by dividing a square into 16s. Using the above methods, you can make a tangram of any dimension and any materials you choose. See, any
Sir,
materials you can.
what is a tangram shape?
A tangram is a kind of playful toy in which basic shapes are part of it. And standard tangram consists of 7 pieces made out of a square. A square is cut into 7 pieces. Each piece, this cutting a square into a small shapes of a definite shapes, which is called a tangram. Tangram is a kind of what is called as a shape creating method. Shape creating method. Later, this has been. Tell me, any questions? So they started to understand, can we have many kinds of tangrams, shapes created with a specific shape. So we are creating using a square, we are creating many shapes using the squares, is it not?
Yes, sir.
One square piece has been broken into 16 squares, in which we use the smaller part and identify the diagonals and cut into pieces such that it becomes only 7 parts of it. So this is a standard 7-piece diagram, which you just assemble it, you get a 7-piece, you can make into a square. Okay, assemble itself into here. The 7 diagrams, in the right side you got the pieces, in the left side you got the tangram square, is it not, made out of 7 pieces. So what is the question here? The tangrams consists of a square made into 7 pieces. Is it clear?
Okay, sir.
This
In
kind,
every diagram, it will.
not every, this one kind of standard diagram we can have 7 different shapes of different sizes, basic shapes. Any questions? Shall we go to the next level? Okay, after that one, once you are able to look at the triangles, you can always you will get you go to internet, search for it, you'll get how to make many shapes using that. Abstract shapes can be done. The shapes can be animals, the shapes can be objects, the shapes can be trees, flowers, and everything. The 7-piece also standard to create a kind of abstraction for many shapes. So tangrams helps to create a fish, a rooster, a duck, a camel, whale, bird, all these. So you are not drawing, you are using the piece in order to make a shape kind of thing, which is basically a similar kind of a shape that popular shapes. Like you look at this, you are looking at many various kinds of shapes.
Yes.
So normally now we can create with 7 itself 50,000 shapes. How many?
50,000.
50,000 shapes can be created, abstracted with only using the 7 pieces. It looks like it is similar to a bird, a tree, an object, and a shape that you are familiar with it. Okay, that's the power of tangram. So tangrams helps you to think a shape abstraction. Once you are able to look into this kind of thing, these are the tangrams which actually facilitated. You can download anything. So basically, it's a deceptive, simple set of 7 geometrical shape. So basic standard diagram, which will have 2 triangles, smaller, 2 triangles of bigger, 1 medium triangle, and 1 square and polygon. So when pieces are arranged together, they suggest an amazing variety of forms embodying many numerical. You can also do the numbers. You can also do the alphabets. That 1, 2, 3 can be done with tangrams. You can do alphabets A, B, C, D with the tangram. Similarly, geometrical shapes. So tangrams help us to abstract into a shape of forms of a particular kind, and it may be a figure, it may be a shape, it may be numerical representation. So that's why. So, and if you find out the area of this triangle, this another concept. So the 4 square, 4 into 4, how many are there? How many are there? 16 square centimeters.
16 squares.
So now the area of the triangle, this should be also 4 into 4. Lavanya, Putani, one nimisha, just a minute. Hello, voice audible? Okay. Okay, now the question is another kind of mathematical understanding. Look at this picture now. We made it with how many smaller square? Let's say if you make it 1 centimeter square, there will be 4 centimeter by 4 centimeter square that you make it out. Is it not?
Yes.
What is the total area of that? 16 square. A into length into length.
Yes.
Area of a square. Area of a square is what?
Square
length into
square.
length into length. Yes, length into length. So this is length into length. I make it as a 1 centimeter. Therefore, 1 centimeter into 1 centimeter squares. There are 4 such square. Therefore, 4 into 4, 16 square. And if you break into pieces, that you find 1 square here, 2 square here. So this is half of the square. Put together 1 square. Put together, this is 4 centimeter square. This again same 4 centimeter square. This is about 2 centimeter square area. This about, if you look at the parallelogram is also 2 centimeter square, and the square is also 2 centimeter, and smaller triangles of 2 centimeter. And if you add all these number, 4 plus 4 plus 1 plus 2 plus 2 plus 2, what is the total number? 4 8 8 2 10 10 12 13 13 15 16 16 squares. But even though, so this is mensuration that you learn in high schools. Did you learn mensuration? Measuring the, yeah, is it
So,
not?
but we didn't learn about the area of a triangle.
Sir,
No.
maybe for 8 it is there.
So here we are actually, this is called proof without proof with pictures. In the picture itself we can prove it. So this consists of 1 square centimeter square, 1 square centimeter square. This half and half makes 1 square. This is also 1 square. This is also 1 square. Therefore the area of this middle, this triangle is 4 centimeter square. 4 centimeter square. Otherwise, if you find out the, you can take down this picture. It also helps us to understand how to measure the area visually. Area visually, not using the formula. Normally for a triangle, what is the formula? Is half into base into height. Half into base into height. And a parallelogram, what is the formula? For a square, small square also, bigger square, it's length into length. So this is also a kind of understanding your. So if you make it with the 4 cross 4 table, you can also prove that this can also be understood. The sum of the smaller piece square is also equal to the bigger piece area. So area of the bigger square is equal to the area of the 7 different size areas. So it can also be proved. So that's one concept that you can capture. So apart from that, you can also, that's why it's also a tangram is pack. What do you mean by pack? Pack means always say for a parent, for an adult and a child. P stands for parent. A parent can also use the concept mensuration and other things, area and other things. You can find out what is your, let's say you have an house which actually, or you can look at the tiles on your house. You have a tiles on your shapes. Can you have the tiles?
Yes.
So you can look at the tiles. What are the tile shapes? You may start with only a square or rectangle. Later you will find lot of shapes have been used in making the what is called as putting tiles on our surface. What is called as? Any name for it? It's called tessellation. What is that word I am using?
Tessellation.
Tessellation. Tessellation they will call it. Tessellation. Tessellation is make a tile like that. So tangrams is a first step to understanding tile architecture. So tangrams, but it's not only a playing, it's also a business kind of module. Tangrams will lead into a lot of concepts. So tangram is a pack, parent, adult, even the parent will use it, adult, children's and all. It's a learning tool for building STEM skills. What do you mean STEM skills? Science, technology, engineering, arts, and mathematical skills. In maths, tangram is a Chinese puzzle made by splitting a flat square into 5 triangles, a square, and a parallelogram, capable of being recombined to create several different pictures. So that's why you can buy a tangram and do shapes, or you can take color pieces of 4 or 5 color. You can take, make, let's say in each square pieces you get 7. If you have 5 colors, you get 35 pieces. From the 35 pieces, you can have different colors and use these different colors to make shapes and paste it on a cardboard sheet. And can you show it in the next week? Did I say what I said?
Yes, sir.
You take 5 or 6 colors or 10 colors, whatever you get the paper, color paper. From the 10 color, you backside you can make 4 cross 4 and make tangram. Each tangram will have 7 pieces. And you, if you have 10 sheets, how many tangrams you will get?
10.
Tangram pieces, 70 pieces you will get it. But so you can choose any color square, any color rectangle, sorry, triangle, and any tangrams colors. Yours, this one
Sir, I
triangles,
didn't
and make a.
understand.
What I am saying, you can take 10 different color paper. Okay,
Hmm.
each color piece you can make. Can you not do it?
Yes,
Sir?
sir.
In each color piece, you can take one piece of paper like this, color paper, and you can create in one color, red color on tangram pieces, blue color on tangram pieces, green color you can make a tangram pieces. Got it? What I'm
Sir,
saying?
like this half rectangle. So, no, half triangle.
Small triangles and medium triangles and
Like
colors.
this.
So yes, 10 different colors triangles you will get it. 10 different squares you will get it. 10 different smaller triangle you will get it. 10 different bigger triangles you will get it. Is it not? You can, if you use 5
Yes,
colors,
sir.
you get 5. So you will have many pieces like this.
Yeah, sir. Yes, sir. We can
You
do
now you
this.
Now you got what I am saying.
Yes, sir.
Once you know these things, then you can create shapes like this, basic colors with different shapes, different color pickup and medium size, and you can have the chart which is available in the internet to make shapes. With the answer, it will be there. This is the answer. This is a puzzle. It will be like this. Is the answer. But instead of using only one black color, you can use different colors. Different colors. Can you not do it?
Yes, sir, we can.
This what actually I want to make a chart next week. Whatever shapes that, as I said, you can make numbers, you can make alphabets. You have to search in internet how to make alphabets. A tangram alphabet, you have to know it. A tangram numbers, you have to know it. And tangram geometrical shapes, you have to know it. Then tangrams pictures, tangram animal like things, tree like things, or whatever object like things that you have to do it. This is a challenge I am giving to you. So will you able to this made up of only one color? I don't want one color. I want in different colors. So in order to different colors, you have to take the piece, make it into 7 pieces, and use the colors to make different using the break the here. All these are made up of 7 pieces only. Look at this: 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Each
Even
shape
ours
consists.
should be in 7. This one.
Which one? What's your question?
Even our picture will
Normally, that is the challenge. Challenge is you have to do the shapes with using only 7 pieces.
Oh.
That is a challenge. So, but answers are available with the 7 pieces. Black is available. Colors are available. You can see the colors. I'll show you these colors. Colors are available.
Sir, if we don't have chart papers or origami sheets, can we do it with black?
Yes, you can use any two
Or
colors.
sketch
White paper.
pens?
Yes, you can sketch pen, use it, colors it. You can color the sheet and do it. That's your kind of abstraction. I'm not saying you can do it only white paper. You can do it, color it and do the paper. Definitely you can do it. It's not a problem. What I'm saying is that's the thing that you have to learn to abstract. So once you are able to make a one tangram of 7 pieces, then these triangles and these squares are used to create many kind of amazing forms of shapes of numerical kind, of geometrical kind, and number kind, alphabets kind. That you want to do it. And apart from that, I told you can find the area. And tangrams, basically it's a Chinese puzzle, but it has started with many kind of, and they teach the kids about open in basically helps geometrical terms develop strong problem solving terms. One of the geometrical terms on one or two, I just started with it. Congruence, similar. These are the geometrical terms that you will use it. Is it not? We also said about a parallelogram, in which you said two sides are equal, right angle triangle. So what are the things that you are actually understanding the same from this kind of maths? Okay, once you are understanding these triangles, this tangent will help to probe many kind of conceptual, we call it as this is called perceptual thinking. Can you percept? Can you think like this? Can you think like that without words? Think without words. Think with the shapes. Think with the shapes. That means you have to think like a fish using these shapes. That is called this kind of, we call perspectival thinking. Think like a shapes, or non-verbal thinking also it's called, without using word. Visual spatial awareness, creativity, and also it's about congruency, symmetry, area, perimeter, geometry. All these things are part of mathematics. You will learn a lot of congruence properties, lot of symmetrical properties, lot of area properties and perimeter. And so these two smaller triangle, if you keep one above the other, their sides are equal, their angles are equal, they're of the same size, their you can say left side is equal to right side or nothing. So it also teaches symmetry concepts, it also teaches congruence concept, area concept, perimeter concepts, and geometry concept. So you have only in the textbook you will come across all those terms, is it not? Textbook ಅವೆಲ್ಲ ಪದಗಳು ಬರುತ್ತೆ ಅಲ್ವಾ?
Yes, sir.
ಆ ಎಲ್ಲಾ ಪದಗಳನ್ನ ನಾವು ಇವಾಗ ಒಂದು ಆಟದ ತರ ಇರುವಂತ ಒಂದು ವಸ್ತುನಲ್ಲಿ, ಎ ಟಾಯ್ ಲೈಕ್ ಥಿಂಗ್, ಎ ಪ್ಲೇ ಲೈಕ್ ಥಿಂಗ್. ಯು ಪ್ಲೇ children's, it may be a play, but from the playing you also understanding the geometry, you also understanding the arithmetic, you're also understanding the algebraic concepts, is it not?
Yes.
That's what actually I want to say. Tangram stand as a candidate to learn a lot of basic high school and PU mathematics. If you start, apart from, if you are only stick on to that kind of things, you can become a much more artistic in nature. And if you properly go to the next level, I showed one data set where actually many shapes were there. A picture has been broken into smaller shapes, not necessarily of like triangle, squares. It is a irregular shapes, but which are irregular known shapes. Irregular, what I said, known shapes. There are irregular shapes, but which will be known to you. Using that one, you can learn a lot of things. So basically a tangram for a student recognize and identify geometrical shapes. They will also become confident in understanding geometry and how geometrical shapes can be decomposed. What is the word decompose? What do
Remove.
you break into smaller parts?
Yeah, sir. Breaking into smaller pieces.
So take a square, break into smaller pieces. That's the concept it is telling. How you are breaking that bigger square has been made into 4 cross 4 smaller square. Using those, I am making a parallelogram. I am making a triangle. I am making a square. So I am decomposing a square into smaller shapes of a triangle, shapes of a square, shapes of a parallelogram. Is it not a kind of decomposition of the shapes? And again, take those decompose and again use the recomposition like music. You
Decomposing.
so you will come across in music, compose it. How do you compose? Using the different tones, you will compose it. Similarly, using the different shapes, you compose into different objects that you are familiar with it. You may be familiar with a bag. Can you make bag with that one? You may have a cup. Can you make cup with it? You have seen a dog. Can you make dog from these broken pieces of tangrams? That's what actually you learn. So this composition and decomposition concepts can also be understood. So this is what actually we call it as visual spatial skills. What I said? Visual
Visual.
spatial space in 3D, not on the plane. You have to think in the space. You have to think spatial. You have to think in 3D. Sir taught about 3D geometry. So you have to think space shapes in 3D. So that's called spatial thinking. Visual thinking will be improved for you. So the moment you start with playing very Tangram learning is most important. So take some. So Tangrams are available 50 rupees. It is if you are not able to buy it, make it your own using the paper, cardboards, wood pieces, and whatever you got it, cut into 7 pieces and make Tangrams to create many kind of wonderful things. Is it not wonderful to go behind Tangrams? Tell me yes or no. Is it not wonderful to learn
Yes,
maths through
sir.
Tangram?
Yes, sir. It is very interesting. Like
Very
it is
nice.
like playing with
Yes. So
shapes.
now I'll come back where these tangrams were invented, basically were first introduced to the German public by industrialist Friedrich Adolf Richter around 1891. The sets were made up out of stones or false earthware and marked as anchor puzzles. So that is the sort of part. So he created the popularly, even though it was there, somebody has taken this search. So he was the one who had created, and it has been introduced a product as a toy to the public, and that's what actually basic. And there is again, it's a puzzle. You have the rules is tangrams are just simple. The pieces must be connected, they must be flat, no pieces may overlap, you can't keep one above the other. Tans anta karita, the smaller pieces are called tans can be rotated or flipped, changed into top or bottom to form a shape. All 7 tans must be used, and each complete puzzle must contain all 7 tans. So you have a puzzle of a tan made up out of tan shapes. Small tans, all the 7 will be used to create a tan. So use all the 7 pieces. Don't overlap. It should not be separated. It should be touched. So they should be connected. They must be flat. It should not be like, you should not keep like this. They should be flat, and you can rotate it. Each tan can be rotated in many ways. So that's what actually you can rotate the tan like this. So take a tan. So tan can be rotated, and tan can be flipped. Tan can be tan can be flipped, but each tan should be connected. Each tan should be connected. You connect. Anyhow, it should be connected at one point. That's all. It needs connected. You can connect it anyway. The puzzle is the rule only thing, and all 7 pieces must be used for the standard tan puzzle. So that's what actually, and each completed puzzles must contain. So I did not talk about the puzzles. Puzzles are available outside, and puzzles I said 40,000 as far as my knowledge goes here. More than 50,000 only using the 7 pieces they are done. And what I said, the same tiling of the plane also done. Now you got the tan applications also. Apps are available on your mobile, and various kinds of tans are available. You can download and play with tan apps, tan mass puzzles. Those are the TanGram playful puzzles available from Google Play. Various kinds of tans. These are the various kinds of tans which actually I showed. So these are the that is available, which actually visual thinking helps. So basically, this is, I want to end up that session with giving this kind of notes. So already 1:15. So it makes you to challenge to create shapes of known from a 7-piece rule. And that's why the whole concept of tangrams, apart from that, today you got a spring tangrams using the flowers and other things, spring seasons. Printable tangrams are available. As a child, it's a curious, you can learn a lot of tangrams. These are the variants of triangle which I started. So from the triangles. So before ending, I want next session, we'll continue with the mathematics of the tangrams, where actually I'll be looking into Pythagoras theorem. Looking
Sir,
into
in the next session, can we do more about maze?
okay. I will take about the maze, and I'll talk about maze mathematics also. I'll speak about why the maze played a key role in mathematics. So your request, I'll just do it. But at the same time, you should be able to understand what's a line, what's a curve line, how the curve lines can also be thought about it. And I have an image which I'll share it using only what actually you have a maze in which the human shape also become a maze. Got my pitch? The curve should also make a human picture. Curves also makes a human picture. So he becomes a maze in a maze. He himself become a maze kind of piece. So that I'll show you how to create a maze person inside a maze also. It's also a maze. And that's what, again, last class we talked about the creating a labyrinth. But I did not talk about, sir wanted to talk about mathematics of maze. I'll be speaking like today, a little bit I started. This I want to continue how the perimeter, congruence, other property that you learn in high school can be mapped down to the tangram. That was actually some problem was there in my system. I was not able to create the suddenly it went out the presentation which I started. So I used my old one to do it. Anyway, I'll come back to you. So next you say whether the class was interesting.
Sir, it was really interesting, sir.
No, my question is about, it's not a play, it's a maths can be learned with play. So beke beku ganita beku, maths learn maths. Will you tell all of us? Maths,
Sir.
maths.
Learn maths.
Max, learn max.
Learn maths, mathematics, learn maths. We want maths. Like we want
Maths.
maths to learn. We want maths to learn. We want maths to
Learn.
Okay, that will help you to a lot. So thank you all for participating in this session. It's the kind of, I hope this not like I did magic. I want to do it magic. Some failure was there. Oops, to an extent you enjoyed my class today.
Yes,
Yes or no?
sir.
Yes, sir.
Yes, sir.
Thank you. Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay, you have to
Thank you, sir.
Thank you, sir.
you can make a chart. You can make it in your this one also. How to make tangrams in using your what board? What software you are using? Sir is teaching.
Excel.
Sir is teaching in what?
Scratch.
Scratch and tangrams. You just check it out.
I'll
Okay.
make some.
Oh, you will make them. That's the challenge that you are taking. Somebody will take in the paper and show me the charts. Okay. Thank you.
Yes, sir. Bye.
Bye, sir. Have a nice day.
Hello, sir. Idira,
Bye.
sir. Sir. Idira.
Kiran, sir.
Kiran, sir.
Sir.
Left.
Yes, sir. Kiran, sir is not here.
Okay. No problem. You make a chart next week. Will you do it?
Yes, sir.
Okay. You make a chart and you can understand what you understand, basic things that also you should explain it. Then only I'll start with doing the maze. Huh?
Okay, sir.
So you should explain a little bit whatever understanding that you're done about tangrams. Okay.
Yes, sir.
Okay. Thank you.
Bye, sir.